Hey there, science fans! Welcome to our countdown of the top 5 mysteries of chemistry. Get ready to explore the strange and wonderful world of atoms, molecules, and the reactions that make our universe tick. These are the questions that continue to baffle scientists and spark curiosity, pushing the boundaries of human understanding. So strap on your thinking caps because things are about to get elemental. Get it? Let's dive in. Now let's dive into one of the most controversial and captivating mysteries in chemistry: water memory. Imagine if water could remember substances that were once dissolved in it, even after those substances have been diluted away to the point where not a single molecule remains. This concept, known as water memory, was first proposed in the 1980s by French immunologist Jacques Benveniste. He claimed that water could retain a memory of substances it had been in contact with, which could have profound implications for homeopathy and other fields. But here's the twist. The scientific community was, and still is, deeply divided on this topic. Many experiments attempting to replicate Benveniste's findings have failed, leading to widespread skepticism. Critics argue that the results could be attributed to experimental error or contamination. However, some researchers continue to explore this puzzling phenomenon, using advanced techniques like high-resolution spectroscopy and molecular simulations to investigate whether water can indeed retain information about its past. So what's the truth? Is water memory a revolutionary discovery waiting to be validated, or is it a scientific mirage? The jury is still out, but one thing is certain. The mystery of water memory continues to captivate and challenge scientists, pushing them to question the very nature of water and its properties. Could this enigmatic behavior of water hold the key to new scientific breakthroughs? Only time and rigorous research will tell. Stay tuned as we unravel more mysteries in the fascinating world of chemistry. Okay folks, buckle up because we're about to enter the realm of the invisible, the mysterious, the downright baffling dark matter. Here's the thing, when astronomers observe the movement of galaxies, something doesn't add up. The galaxies are spinning way faster than they should be based on the amount of visible matter we can detect. It's like watching a car zoom around a racetrack with an invisible engine propelling it forward. Scientists believe that this invisible engine is dark matter, a mysterious substance that makes up a whopping 85% of the matter in the universe. Now here's where chemistry comes in. Although we can't see dark matter directly, we can study its effects on the visible universe. By analyzing the distribution of elements in galaxies and the cosmic microwave background radiation, the afterglow of the Big Bang, scientists are trying to unravel the nature of this elusive substance. Some theories suggest that dark matter is made up of exotic particles, unlike anything we've ever observed before. These particles would interact very weakly with ordinary matter, which is why they're so hard to detect. The search for dark matter is one of the most exciting frontiers in modern science, and chemists are playing a crucial role in this cosmic detective story. Who knows what incredible discoveries await us as we delve deeper into the mysteries of the universe. Mystery 3. The Mpemba Effect. Why hot water sometimes freezes faster than cold water. Have you ever been in a hurry to make ice cream and wondered if starting with hot water would actually speed things up? Well, you're not alone. It sounds counterintuitive, but there are times when hot water can actually freeze faster than cold water, a phenomenon known as the Mpemba effect. This puzzling observation has been around for centuries, with even Aristotle and René Descartes pondering its mysteries. But it wasn't until 1963 that a Tanzanian student named Erasto Mpemba brought it to the forefront of scientific inquiry. While making ice cream, Mpemba noticed that his hot mixture froze faster than his classmates' colder ones. Intrigued, he investigated further and found that, under certain conditions, hot water indeed froze more quickly than cold water. But why does this happen? Scientists are still trying to fully explain the Mpemba effect, but several factors might be at play. One theory suggests that evaporation plays a role. Hot water evaporates more quickly, reducing the overall volume that needs to be cooled. Another possibility is that dissolved gases in the water, which can act as insulators, are released more readily at higher temperatures, allowing for faster cooling. Additionally, convection currents, the circular movement of fluids due to temperature differences, might also contribute to the effect. The Mpemba effect reminds us that even seemingly simple phenomena can hold surprising complexities. It's a testament to the power of observation and the importance of questioning everything, even if it seems counterintuitive. Mystery 4. Non-Newtonian fluids. The enigma of strange behaviors. Have you ever wondered why some fluids don't behave like you'd expect? Well, it turns out that non-Newtonian fluids like a cornstarch and water mixture can act like both a liquid and a solid depending on the stress applied to them. When you apply a sudden force, these fluids become rigid and solid-like, but when you apply a gentle force, they flow like a liquid. Scientists are fascinated by these fluids and study them to understand their unique properties and potential applications. Some experiments involve testing these fluids under various conditions to see how they respond to different types of stress. Theories suggest that the behavior of non-Newtonian fluids is due to the complex interactions between their particles. Despite the challenges, the study of non-Newtonian fluids is one of the most intriguing areas in modern chemistry. Unraveling the mystery of non-Newtonian fluids could lead to innovative materials and technologies. The enigma of non-Newtonian fluids continues to captivate scientists and fuel our imaginations, pushing the boundaries of what we know about the behavior of matter. Mystery 5. The nature of glass. Solid or supercooled liquid. We see glass every day, from windows to drinking glasses to smartphone screens. But have you ever stopped to think about what glass actually is? It's a solid, right? Well, sort of. But also kind of not. Here's the thing. Glass is an amorphous solid, which means its molecules aren't arranged in a neat, repeating pattern like in a crystal. Instead, they're kind of jumbled up, like a liquid frozen in time. This unique structure gives glass some interesting properties. For example, it's transparent unlike most other solids, and it can be molded into different shapes when heated, unlike most other solids. But here's where things get really weird. Over very long periods, glass can actually flow, albeit extremely slowly. That's why some ancient windows are thicker at the bottom than at the top. So, is glass a solid or a liquid? The answer is, well, both. It's a solid in the sense that it holds its shape, but it also exhibits some liquid-like behavior over very long timescales. Scientists are still trying to fully understand the nature of glass and how its unique structure gives rise to its unusual properties. It's a fascinating example of how even everyday materials can hold deep scientific mysteries. Thanks for joining us on this journey through the mysteries of chemistry. From the origin of life to the nature of glass, we've explored some of the most mind-boggling questions facing scientists today. Remember, science is all about asking questions, exploring the unknown, and never taking things for granted. So keep your curiosity alive and never stop learning. Don't forget to like, subscribe, and hit the bell icon for more intriguing science content. Until next time, stay curious.